Welcome. We are at 9.4, task 4, and it's called Wow, That's Weird. Okay, and weird in this case is saying not a doctored up photo, but weird mathematically means very different from the mean. Okay, and the way you can measure that is the number of standard deviations. And the number of standard deviations is the z-value. So when you think of z-value, think about how many standard deviations away from the mean it is. If it's positive, it's to the right of the mean, greater than the mean. If it's negative, it's to the left, right, less than the mean. And the way that you calculate the number of standard deviations is to take your data value, subtract your mean, and divide by your standard deviation. And that allows you to compare across two very different populations, as long as those are normal distributions. Okay, it doesn't really matter the values, but you can compare relatively what percentage are they at. And that's what allows us to compare. This is the normal distribution. The main thing I'd reiterate here is the fact that 68% is within one standard deviation. If you include two standard deviations, it's about 95.5%. A lot of people just say 95. And if you go within three standard deviations, which is fairly dramatic, you'll get almost all the data if it's normally distributed. In this case, you can see it's 99.7%. So for example, you can do that. I'm not going to do this for all these, but you can plug in those values. This is remarkable. A 3.7 z-value, that means more than 3.7 standard deviations away. That would be way over here, extremely unlikely. Okay, this example of a positive, right? You can also have a negative value, and so this would be less than the mean, negative 1.9. Remember that this normal distribution is symmetric, so positive and negative, all you really need is one of those numbers, and given the fact that it's symmetric and the other half is 50%, you can also use those for your calculations.